Hello students, welcome to the next video on Physics Class 7. The chapter that we are going to discuss is energy. So before we understand energy, we need to understand what is work. Now scientifically speaking, work done by a force when it displaces a body along its direction. Like suppose this pen is lying here and I push it and the pen moves. I can say that work has been done because the pen is moving from one position to another position. So, or if I take my bag and move towards a direction, then I can say that work has been done. So, work done is equal to force into displacement. Now, you know that force is having the unit Newton and displacement is having the unit meter. So work done is force into displacement, that is Newton into meter, Newton meter or joule. The SI unit of work is joule. And how can I define a joule? 1 joule is defined as the amount of work done when a force of 1 Newton displaces a body through 1 meter. So what is the definition of a joule? As I told you, it's the amount of work done when I am moving with the force of 1 Newton and moving the object through a distance of 1 meter. So why have I discussed work before I go to energy? It is because you can do work when you have energy, right? And you know that we eat food and because of respiration, the food is broken down and we get energy. So it is very important to know that scientifically, if we are speaking, work is done only when a body is displaced. For example, if I ask you whether a man standing with a suitcase on his hand and waiting for the bus for his office, can we say that he is doing work? No, because he is not moving, he is standing at a point, so he is not doing any work. Or if I tell you that some boys are playing football in the field, so are they doing work? Yes, because they are moving around and playing. So it is very important to understand the actual definition of work in relation to science. So now moving to energy. Now you know that suppose you play for a long time or you walk for some kilometers, you get tired, right? And this is because you do work. Your body is using up energy for that. And also you can say to do work, it is necessary to have energy. And energy is the cause, we can say, and work is the effect of it. And they are directly related to each other. Even the SI unit of work and energy are the same. So you know that SI unit of energy is nothing but joule. So how do I define energy? It is defined as the ability of a body to do work. There are some other units of energy as well, like we have calorie, erg. So you know that 1 joule is 1 Newton meter. So if I speak in terms of calorie, then it is equal to 4.186 joule, or we round off it to 4.2 joules. So remember that 1 calorie is equal to 4.2 joules. Now we are having different forms of energy. And it's very interesting to know that you cannot create energy or destroy energy. You know, children, it's just we are converting it from one form to another form. And if we categorize the energy firstly as mechanical energy, I'm writing ME in short. So that is the energy which is possessed by a body due to its position or its motion. Like maybe a body is still or kept in a certain height. It does possess some energy. And even if it is in motion, it is containing or having some energy. So we can divide that energy into two types, that is kinetic energy and potential energy. So you need to remember that energy possessed by a body, whether when it is in motion or when it is lifted to a height with respect to the earth's surface or the ground, then it does possess energy. So like if I can say that a boy running or a girl running, she has energy. She is using energy to run. And similarly, a stretched rubber band, it is containing energy. Now, when we talk about kinetic energy, dear friends, you need to remember that the energy possessed by a body by virtue of its motion is called the kinetic energy. And also like flowing water, moving ball, flying bird, running girl, all of them possess what energy? Kinetic energy, because they are in motion. And also remember that you are able to do work because you have energy. And when a moving body, suppose it comes in contact with another body, it will either make that body move or it will either distort or change its shape. And then you can say some examples of kinetic energy, like when I'm moving my leg to kick, so that is kinetic energy. If you throw a stone on any glass window, it may break or it may not break, right? So that is the moving. The stone is moving, right? And it carries some energy so that it can break the glass or it cannot break, but something is definitely there in the stone which I'm throwing. That is the energy. Then the next example can be like, suppose there is an accident on the road. You know that generally what happens, suppose there are two trucks or two bikes which have come and hit against each other. Both of them possess some energy because they were moving, and that is why when they collided there is a lot of injury. So all these are happening because of the energy contained in the body, remember students. And the other type of energy which I was telling you is a potential energy, and this is the energy possessed by a body by virtue of its position or the change in shape. That kind of an energy is a potential energy, dear students. For example, I can tell that suppose I am picking up a stone and raising it to a certain height. So that stone is containing the potential energy because I have raised it to a height. Also, you know that the water tank from where the water is coming to our houses, they are generally made little above at a height, so that water inside them has some stored potential energy. So it's very important to remember that energy, the mechanical energy, can be categorized into two types, kinetic and potential. Kinetic is due to the virtue of motion, whereas the virtue of the position or change in shape makes the potential energy. Now there are some points on which, or factors you can say, on which the kinetic energy depends. It depends upon the mass of the body. Now you know what is mass, right? And if the mass is more, or the object is more heavier, we can say, then what happens? The kinetic energy will also increase. The mass of the body is directly related to kinetic energy, okay? And the second one is the speed of the body. When I'm telling the speed of the body, this is also again directly related and or directly proportional to the square of the speed. The kinetic energy is directly related to the square of the speed. So here half mv square, this is the formula actually of kinetic energy, where this m is the mass of the body and the speed is the v, and you can see it is v square. So if the speed is increasing, that is the more faster an object is moving, the more kinetic energy it has in it. And the next type of energy, that was potential energy, as we were discussing, it depends on the three factors, that is mass of the body again, that is directly proportional, greater the mass of the object, more will be the potential energy in it. And suppose you take a small stone and a big stone and you raise both of them to a certain height. The bigger stone will have more potential energy because its mass is more. Simple. And then it depends upon the height of the body. As I was telling you before, it is height of the body above the ground. So more you raise the object. Suppose I take two stones of the same weight or the same mass, and one I raise till a certain place from the ground, a certain height, and the other one I raise more above. So what will happen? This is having more height and this is having less height. The stone is having the same mass here, okay children? So whichever height will be more, that body or that stone will have more potential energy. And the third point, it depends upon the acceleration due to gravity. Now this is something related to, gravity. It changes from equator to the pole of the earth. So it also depends upon the acceleration due to gravity. So here we can say that potential energy, or PE, is equal to mgh. That's the formula for potential energy, where you can see all the three factors: mass, acceleration due to gravity and the height. Now, potential energy again are of two types, dear students. So, one can be called the gravitational potential energy and the other is the elastic potential energy. If you see what is the gravitational potential energy, it is the energy gained by a body when it is raised to a certain height. So, from the ground, raising anything to a certain height, then it becomes the gravitational potential energy. Like if you keep a stone on a hill, it will have more energy than a stone which is on the ground, right? Water is stored in dams or reservoirs at a height, and this is because the water will possess potential energy, and when it falls from there, it will have more capacity to move the turbines which are there. Okay. Also, the other kind of energy is the elastic potential energy. This is the energy stored in a body when work is done to deform, stretch or compress anything. Like when you pull a elastic, what do you see? When you pull elastic and you leave it, it moves away from you, right? It falls in some other place. So this is happening because that energy, when you're pulling the rubber band, it's storing some energy. That energy possessed by that rubber band is the elastic potential energy, and when you leave it, it takes its original shape also, but it flies in the air before it regains that shape. Okay, so example of that elastic potential energy can be any compress, spring, an arrow drawn in a bow, like when you pull a arrow in a bow. Yes, so that is a example of elastic potential energy. Even a catapult, you might have seen the local children, they have a catapult in which they put a stone and they hit a mango or some fruits which are there on the trees and try to drop them. Okay, so those kind of things are possessing the elastic potential energy. So dear students, I'm very sure you might have understood how work and energy are related, what are the different kinds of energy, and how in a day-to-day life we can see all these energies as well. I would like you to comment in the comment section some examples of kinetic energy according to you, and thank you for watching.